In this video, we're going to talk about polynomial inequalities. And we're going to talk about this particular expression right here, and we want to find when it's greater than 0. So the first thing I want to do is I want to do a little review and remind ourselves that we have the roots. This root would be at 4, which is right here. And again, the multiplicity is 2, which is why it's bouncing here. It's not crossing through at the root. And this one here is the root is at -1, and it's crossing through because this multiplicity is odd. So, and we have no root at 0. There is no x here, so this is just simply a stretch or a multiplier. So what we're going to do is we're going to find where it's greater than 0. And what we're going to do is basically refer to the graph on this. So what I look at is I look for all the values. Whoops, I need a highlighter, please. We look for all the values that are greater than 0. Oops, a little bit of that line went below, but we see that the top half of the graph. And when I'm looking for the portion of the graph that is greater than 0, it is this part here. And of course, where we go between above the x-axis and below the x-axis happens at our roots. Our boundaries are at the roots. And when I look at this, this is going to be above the x-axis here, and all the rest of the time it's below the x-axis, or greater than 0 here. Well, the time when it's greater than 0 is from all of these points until I get to 4. So the solution here is from negative infinity, I'm sorry, I said 4, I meant -1, going to -1. We don't want it to be equal to 0 because we don't have a greater than or equal to 0, and this is the only place here. So parts that are above the x-axis is when we look for things that are greater than 0. Below the x-axis is going to be less than 0. But we can also use test points. So again, the boundaries are always going to be at the roots, always, always. So we can create my number line where I have the values at, again, -1 and 4. So what I'm going to do is I'm going to choose values that are in those intervals. So maybe -2, there's a value 0, and 5. So I'm picking those values, and what I'm going to do is I'm going to put it back into the inequality. So let's start with this first realm. So I've got -5, and I got I said x was -2, so I'm going to put those values in. -2 plus 1 cubed, and I want to see if that number is greater than 0. So I've got -5. This is going to be squared, so it's going to be -6 squared, or 36. And then this is going to be -1 cubed, which is -1. And is this number greater than 0? Well, -5 times 36, I'm not sure what that is. It's going to be a -180. Multiplied by -1 greater than 0. Yes, -1 times -180 is positive, so yes, that's true. So yes, this is part of the solution. So let's try the test point of 0. So again, we're going to go -5, 0 minus 4 squared, and then 0 plus 1 cubed. And I want to know if that's greater than 0. So we got -5, this squared is going to end up to be 16, and then I've got 1. Well, even before I multiply, I've got a negative times a positive times a positive. That's going to end up to be a negative number, which is not bigger than 0. So this is not going to be part of my solution. And again, if you multiplied it, would be 81. But I just want to point out that sometimes we don't even have to multiply, that we can just simply put the values in and see whether it's going to end up to be negative or positive. It's really simple that way. So putting into the last one, we have -5, and we have 5 plus 4 squared. We have 5 plus 1 cubed, and this is going to be greater than 0. See if it's greater than 0, excuse me. So we have a negative number multiplied by a positive number multiplied by another positive number. So negative times a positive is going to end up to be negative, which again is not going to be the case. And you can go ahead and multiply and find that huge number. So this is also not true. I'm going to put little insignias here. So what we have is, we have that this is the only realm that worked. This is the only interval that worked, was from -infinity to -1, which agrees with exactly what we said when we shaded our graph. So the other thing that I put on the notes above is that we have to make sure that when we're looking for this, that 0 is by itself on one side. So when I'm given this particular inequality, I have to make sure that I add 8 to both sides to get the 0 by itself. So Now what I'm going to do, again, the roots are at 4 and 2. I factored that one. You can do the quadratic. I factored that, or factoring that one. And then here's my roots on that one as well. So I already have the graph laid out. And what I'm going to do is I'm going to see where the interval applies. Well, on this one, I want to go greater, so I want all the values above the x-axis. This one wanted less than, so I want all the values below the x-axis. And this one wanted, now it looks tricky, it looks like less than, but if you notice the inequality is on this side. So 0 is less than the graph, or the graph is greater than that value. So I can easily put up the answers. Well, the answers are going to be this side, which is negative infinity, stopping at that first root, union with the next root going to infinity. On this particular one, the only value that's shaded is down, oh, I didn't circle that one there. The only value that is shaded is in between the two roots. And this value I have, this particular graph I have shaded, the values are between the first root to the right and the next one, along with the last root up to infinity. But what I also decided to do is I'm going to do the same values using my test points. So what I have here is, as I have everything worked out, but I want to point out what we're doing here. So again, I made a timeline with my two roots, and then I chose a value that was inside to the right, smaller than that, the next number, and then what was the other number I chose? I chose 5. So this is when I chose 1, and I tested it. It did work. So this is part of the solution, which is exactly what we said. Now be careful. We're saying that this interval from negative infinity to 2, sometimes we get a little rushed, and I have people put 1 in the interval, or part of the end of the interval instead of the test point, as a test point. So then we did 3. When I tested 3, no, it didn't work. So that's also not in the interval, but 5 did work. And so we go in from here. And again, if you notice on this one, I chose negative 2 as a test point, 0. Negative 2 did not work. 0 did work if you look in the green. And the purple or trying 2 did not work. So the only thing that worked was in this interval, which is exactly what I said from shading. Now some people would watch this and go, shading the graph is a lot easier. Can I just shade? You can right now, but when we get into section 8.5, the rational inequalities, it will become a little bit more challenging. So I want you to see the test points as we go forth. So we have negative 5, and that didn't work. I tried 0, and that did work. So that's one of my inequalities, or one of my intervals that works. I tried 2, and that didn't work. And then I tried, looks like I tried 4, and that did work. So this is my other interval. So it looks like I have from negative 4 to 1, and I have 3 to infinity, which is exactly what I said here.